Good morning guys, welcome back to another video, and today I'm going to be doing a more detailed look at the thunderstorm risk across parts of the UK today, especially for parts of eastern England and eastern Scotland where there is the risk for some more active storms. And also I'll probably give a bit of an explanation behind my forecast here, which you can find on my website and Twitter as well. But just talking about that forecast, you can see we've got this moderate risk, which is level 4 out of 5. Across parts of northeast England, and that's valid for the afternoon today. So a risk of some thunderstorms there, and then you can also see a risk of thunderstorms elsewhere across parts of Ireland, Northern Ireland, eastern Scotland, perhaps Wales and the North Midlands as well. But I thought I'd start off by giving a bit of an overview of the situation, because that's kind of going to really help to illustrate things. And you can see this is the 850 HPA temperature chart, and 850 HPA is pretty much a fancy way of saying the temperature at 1.5 kilometers or about a mile up in the air. And this is pretty good for showing the air mass at play, and as you can see, we've got lots of these yellow orangey colors moving up towards the UK during the afternoon, and especially across parts of eastern England and up towards Scotland. You can see we have those yellow orangey colours, which is indicating a warm and humid or moist air mass. And also you may notice here, as you probably noticed there with a big change in the colours, but we've also got this cold front moving in to the UK during the afternoon. This is a Met Office surface pressure chart, by the way. And what's going to happen when we get the lift from the cold front bumping into the warm moist air is we're going to get lots of thunderstorms developing, and some of those thunderstorms could be fairly intense. And I thought I'd start off by talking about the environment in place. And one way we can look at the environment is by looking at the instability, and one way we can measure the instability is by looking at the CAPE, which stands for Convectively Available Potential Energy. And you can see here that across parts of England and the Midlands, by the way, this is on windy.com on the UKV model at 3 o'clock this afternoon, but you can see here we've got lots of those bright colours showing up across parts of eastern England during the afternoon, and also kind of in that range of 1,000 to 1,500 joules per kilogram. And anything in the UK really above 1,000 joules per kilogram is pretty significant, so definitely the risk of some pretty active thunderstorms given the instability. But it's also important to look at more than one possibility for instability charts, and that's kind of just the general rule in weather, is to look at the different possibilities. But you can see here, this is another model, the French Rho model, but you can see here it's showing the instability slightly further north, but also slightly higher and kind of focused more into this zone of eastern England. And personally, kind of just looking at the temperature and the dew point and that kind of thing, and the kind of other models as well and ensembles, I think that this general area across parts of eastern England and northern England is the most likely to see this kind of instability. And I would say that this chart here, the arome, is probably the most correct on this. So as I mentioned, lots of instability across parts of eastern England today. And then another way of showing this instability, and this is slightly more complicated, but I can show you something called a skew-T chart, and I think I've shown it in a couple of the other videos I've done, but it's kind of a 3D slice of the atmosphere, of the temperature, the dew point and the winds. And so you can imagine here, this white line on the floor is the ground, so the x-axis is the ground, and then the y-axis is the height going upwards, and then the red line is the temperature and the green line is the dew point. And then the area between this white dashed line and the red line visually represents our instability, and that is because when the temperature of the white line is warmer than the surrounding atmosphere, which is the red line, then the parcel, which is represented by the white line, is going to rise, because if something's warmer then it's less dense and so it rises. And so you can see we've got a fairly large area in between those two lines, showing fairly significant CAPE around 1,500 joules per kilogram, and like I said, anything above 1,000 is fairly significant for the UK. And then another thing to note is this green line here. Actually, I can use this fancy colour picker thing here. This green line represents our dew point, and it's in the Goldilocks zone sort of for storms and lightning activity. And that is because if it's too far over here, then it's going to be too dry and the updrafts are going to get kind of torn apart. They're not going to develop properly. But also, if the green line is too close to the red line, then what can happen is the lightning activity is limited somewhat. But this is, like I said, the just right kind of Goldilocks zone for the dew point to be at, which supports some fairly active thunderstorms at times. And then something slightly more complicated but hopefully still understandable, which is the main reason I showed this chart here, is this box on the top right, and that is the hodograph. And a hodograph is pretty much a view of the wind strength and direction as you go up through the atmosphere. And the best way I can describe it is, if you imagine a balloon is kind of just rising through the atmosphere and it's being pushed around by the wind in different directions, and then this chart is sort of looking at it from above, and that's kind of like the bird eye view. And I think that's kind of the best way that you can really kind of talk about this, or like imagine this chart. At least that's the way that I do. But for example, if you look at the little numbers here, those are the height above the ground, and then the direction, or you can see the direction that's like north, south, east, southwest, and then the strength of the wind. You can tell, for example, if you look at this 3, the 3 lies along this third circle, or fourth circle from the center, which puts it on the 40 knots zone. So that's how you kind of read this chart. You can see at 3 kilometers the wind is 40 knots and it's going in that direction there. But now that I've kind of explained that, hopefully in a way that's easy to understand, but essentially what this chart is showing is a wind profile which is favorable for organized storms, including the risk of supercells. And that is because there is quite a large difference between the dot at 6 kilometers there and the dot at 0 kilometers there at the surface. And if you kind of imagine, if you draw a line between those two, like there, you can see that equals out to around kind of 45 to 50 knots of shear, and that's because the shear is the difference between the wind speed at two heights. And so 50 knots of shear supports the development of supercells because it separates the updraft and downdraft, and it can allow the storms to start rotating. And another thing to add is the the line is straight, which favors splitting supercells, which are supercells that kind of form and then they split apart. So you've got a left moving storm and a right moving storm, and I won't go too much into detail in this video because that will take a lot of time. But that does reduce the tornado risk, but it also means that there is a risk for large hail and strong winds. So essentially, now that I've explained all that, we know that the environment is supportive of severe storms in places today, especially across parts of eastern England in these zones here. However, an environment can be really supportive of severe storms. It could be the most supportive in the entire world, but if you don't have any storms there, then it does not matter at all. And so that's what we're going to look at now, the kind of mechanisms for storm initiation for today across parts of eastern England and Scotland. So this here is the 500 millibar chart, which is showing the wind and the height at 500 millibars. And this is a pretty useful way of looking at the broad picture and the upper level factors in the forecast. And the most notable thing here is this pretty huge and pretty strong upper level trough, and you can see there it's kind of centered just around Ireland, possibly a bit further over there, but the kind of, you can see where it is there. And we've got these very strong purpley colours showing up on this map. Let's change the colour to black because it's easier to see. But you can see we've got those very strong purpley colours showing up here with those strong winds at 500 millibars. And then also, this is kind of getting more into it now, you can see that the winds are kind of spreading apart because you've got a wind barb there and you have a wind barb there. And so as you can see, the winds are kind of diverging, and that's called diffluence when you're talking about the wind spreading apart like that. And when there is diffluence, there is generally more upper level ascent, which means the air is kind of generally rising and the temperature and in the mid levels are cooling and the dew points are moistening, which basically means you're preparing the environment for storms in these areas. And then going into more kind of detailed surface features, you can see here we've got that cold front that I mentioned, and then also take a look at that kind of black line, which is a surface trough, and that is sort of an area of lower pressure and also some convergence in there. And that's really important because that's going to be our main initiator for storms this afternoon. So if I show you the wind chart on this model, you can see where there's the trough, which I just showed on that past the past surface pressure chart for the Met Office, and you can see how the winds are moving in like that direction, and then they're kind of moving in that direction there. And so we've really got this zone of convergence across eastern England for the afternoon, and when the two winds from different directions collide, what happens is they go upwards, and when they go upwards, your storms start to form. So this is going to be our main area for initiation, and you can see the same thing. If I show you the UKV model, you can see the same thing, is that we've got fairly significant convergence across parts of eastern Scotland and eastern England during the afternoon, and so that's where I'm expecting storms to start to form initially. And if I show you, you can see the same thing here. Convergence on all these different models is being indicated, so fairly high certainty on this, and then also the convergence extends into parts of Scotland as well, you can see there. And so that's kind of one of the main reasons for this this kind of enhanced zone there. And so as we get those storms starting to form along the convergence and aided by this upper level support or lift, those storms are going to become intense because we know the environment is favourable. I just talked about that, possibly severe, and also because you've got quite a lot of forcing from these two different things here and this upper level forcing. What I think is going to happen is these storms are going to grow upscale and they're going to organise, and there's going to be some pretty active lightning at times. So we can take a look at what that could look like by looking at the forecast radar by the high resolution Aero model. And you can see there's our cold front, and by about 1-2 o'clock you've got storms starting to initiate across parts of northern and eastern England, and then notice how they kind of become bigger, and by the late afternoon they're forming more of a organised line, and then they move out into the North Sea like that. So that's one thing, one possible scenario which could occur, and I think that's fairly likely. It all lines up with your convergence. You've got your cape. I think this is fairly likely scenario. However, it doesn't, unfortunately, the model doesn't cover areas further north. So let's take a look at what the UKV looks like, and you can see pretty much a very similar evolution to the Aero model. Storms starting to initiate across parts of northern and eastern England due to convergence during the early afternoon, and then becoming active at times, and then moving out to the North Sea. And then also, I think this shows fairly well, you've got those thunderstorms across parts of northeast Scotland as well due to convergence and the upper level forcing. And then also notice how they start to become more organised over time. And this is once it's all left the UK, but this is representing what could happen with the growing up scale into an MCS. So overall, a pretty active day is possible. If things were a little bit further west, then there would be potentially a higher level introduced on this map, but perhaps the bulk of the activity will be over the North Sea, but still it's going to be pretty active, especially across parts of eastern England and eastern Scotland. And that also brings a risk, like I mentioned, of some strong winds, some hail. So I'll talk about the strong winds a little bit more, but you can see the risk of strong winds, hail, potentially supercells, and the very, very small chance of a tornado. I personally do not think a tornado will happen, but it cannot be ruled out just because sometimes when you get these storms near the east coast, the surface wind is slightly changed in a direction which can create more wind shear, which produces more or increases the risk for a tornado. But with those supercells, you've got those stronger updrafts, which bring the risk of, or not bring the risk of, stronger updrafts can carry heavier hail, so the hail can be bigger. So that's another risk today, like I mentioned, the chance for supercells, potentially 1 or 2 across the east of England, and then also some strong wind gusts. But that's pretty much it for the video, guys. Thank you so much for watching and have a great day. Bye.